So these sample exam multiple choice, well, multiple choice in general, always get you guys. So the best way to go through them is to treat them like a full-blown problem, where you draw a picture, you write the directions, you write down anything you know, maybe write some equations, and then try to go through like that. So we'll start doing these for all these problems. So a ball starts at the origin. All right, well, that makes me think of, we're going to have some sort of graph here. Starts at the origin and rolls up a ramp in the positive direction. Okay, so it's going to go up a ramp. All right, the velocity of the ball on the way up and on the way down, blank, blank. The acceleration of the ball is blank on the way up and on the way down. All right, so now we need to figure out, here we got this ramp, and we're going to roll a ball up in the positive direction. And apparently it goes on the way up, and it also comes on the way down. So let's think. We got a ball. It's going to start rolling up the ramp. And as it rolls up the ramp, we know that it'll slow down. And eventually it'll come to a stop. Once it comes to a stop, it's going to start rolling back down the other direction. So I'll switch green for coming back down. So now it's going to start rolling back down in the other direction. And as it goes down, it'll speed up. So if we try to answer this question now, the velocity of the ball, okay, now velocity includes direction. So we got to be careful with that. So we got to make sure that we're remembering that this is including direction. All right, I have to touch my touch off. So this includes direction. Some sort of pause is not letting me write. All right, so the velocity is in the positive direction on the way up and on the negative direction on the way down. So we got positive on the way up and negative on the way down. So we got positive, positive, positive on the way up. Those all work. But then we got negative on the way down. So I can cross out these guys. Okay, so A and C are out. All right, and we're left with B, D, and E. Okay, the acceleration of the ball. Now remember, acceleration is how velocity is changing. So the velocity is getting less and less on the way up. And then it's getting, now I wanted to say more and more on the way down, but I could say the speed is getting more and more down the way down. But since we're talking about velocity, we're talking about direction. So sometimes it works to put numbers in. Let's say on the way up, we had blue. So let's put numbers in here. On the way up, it was 5, let's say. 5 meters per second, and then went down to 3 meters per second, and then went down to 0. And then on the way down, what would we say the velocity is? Well, it's speeding up, but it's going in the negative direction. So I'll say -2 here, maybe, -4 here. And so if we think about this, how is the velocity changing? Well, it's getting less and less, and then as we go on, it's also getting less and less. So the acceleration of the ball on the way up and the way down is opposite to the positive direction. So it's going to be negative, negative. So it looks like the only one that works here is D. D is our answer. Positive velocity on the way up, negative velocity on the way down, and the acceleration is negative on the way up and on the way down. Well, hopefully this will work a little better if I restart this drawing. For number 2, the figure at right shows shows a position versus time graph for a moving object. Which letters in the points is the object slowing down? So we got to remember, on a position graph, they kind of hide it here, but I'll write it big. This is the position time graph. All right, and on a position time graph, what is the slope? Well, the slope is going to be the rise, which is going to be the change in position, over the run, which is going to be the change in time. Now, hopefully, when you see delta x or delta t, the thing that comes in your head right away is this is the definition of velocity. All right, so that means the slope is the velocity. So here we have a positive slope, here we have a 0 slope, here we have a negative slope, less negative slope, and a 0 slope. So if we think about, let's just put some numbers in. Let's say this is a +2, this is a 0, this would be a -2, maybe this is a -3. This is going to kill me if I have to keep writing like this. This is a negative, let's say maybe it's less again, -2, and back to 0. Alright, now the question here is, when is the object slowing down? Okay, slowing down is a speed comment. So when we say slower, when the speed's getting less. So clearly the speed is getting less as it's going from A to B. So it looks like when we're curving, when our curves are approaching 0, that's when we're slowing down. So A and B, it's slowing down. C, it looks like it's starting to go, the slope is increasing, so it's starting to go in a negative direction, it's going faster and faster. Here it's starting to slow down, and F, it's at 0. So I like, for slowing down, I like A. B is kind of right in between slowing down and speeding up, so I guess it's just staying the same. C, it is speeding up because the slope's increasing. E is slowing down. So we just got A and E for a correct answer for number 2. All right, going on here, let's look at number 3. A car traveling at a velocity v takes distance d to stop after the brakes are applied. What is the stopping distance if the car initially travels at velocity 2v? All right, so we're saying here if you go twice as fast, what's going to happen? Let's see, I got a different program here, maybe it works better. All right, so what relates here? We got distance v. Oh, not that one. We got a distance v, distance in v, and the brakes are applied. Now this is the English spelling of brakes, so it's a little different. And so that means we have an acceleration. And if we look at that all together, what relates those two together? So I'm going to write this over here. V, A, and it stops. So this is a stopping distance. So we know V final is equal to 0. This one's killing me too. Why doesn't these want to work well? If I, all right, we try to pause, see if that comes back. All right, so if we look at this, it comes to a stop. So V final is 0. We got initial velocity v and a stopping distance d. And so the equation here that works is we got v final squared. This is killing me. Equals v initial squared plus 2a delta x. If I draw really slow, it works better. All right, so v final is 0. And what we're really talking about is the stopping distance. So let's solve this for delta x. So the negative vi squared shows up on the left side. And then we got to divide by 2a. That gets us delta x by itself. All right, now remember it's stopping, so the acceleration is going to be negative, and that cancels out the negative vi squared, so we get a positive distance. All right, so now we got to look in here. What happens if we double the velocity? All right, so the easiest way to think about this is just plug a number in. So let's say I'm going to start with initial velocity of 1. And so then what do I get? I get my delta x is going to be 1 over 2a. All right. That's as if vi equals, oh my goodness, equals 1. All right, now let's do it again for vi equals 2. So what do I put in there? I get negative vi squared over 2a. And if we do the math on that one, and we just ignore that negative sign because it's going to be canceled out by the a, we get 4 over 2a. So if we look at this here, this one here is 4 times as big as the initial one with vi. So when we doubled our velocity, we quadrupled our stopping distance, and that's because of this square. Right? This is a squared relationship. So with that all in there, if the original distance here, 1 over 2a, would be d, we get 4 times that. So our answer is going to be B, 4 times that. All right. 4 is, this one gets a little bit tricky too because people just like to start averaging things. But we got to be a little bit closer here. So I'm going to draw a picture. A car travels 100 miles, so he goes 100 miles at 50 miles an hour. So that would take 2 hours. All right. And then another 100 miles at 20 miles an hour. So another, oh, I shouldn't write this. This is 100. Another 100 miles at 20 miles an hour. So if you're going 20 miles each hour, that would take 5 hours. All right. So we got to think about the average speed of the car. It's going to be the total distance, or 200, divided by the total time. which is going to be 7 hours. So 200 divided by 7, must be, well, we got to do that math. So don't be afraid to pull out your calculator. We hit 200, man, can you just do divided by 7? Oh, look at that, 28.571. So right away we get our, where'd my sheet go? There it is, sample exam. So that's less than 35 miles an hour. All right. We got one left. See, the figure at right shows an object's position versus time graph. What is the velocity at 9 seconds? So right here, it's 9 seconds. Remember, again, the slope on a position time graph is equal to velocity. So basically, we just want to find the slope here. Since it's a straight line, the slope's the same everywhere. That makes it easy. So I have 0, 5 for 1 point. All right, and then I pick another point that's easy to read. So I guess this one at 9 is good. So I got 9, 35. And my slope's going to be rise over run. So I'm going up by 30. And the run is 9. So 30 over 9 is 3 point something. Looks like this is the closest answer. All right, there you go. Sorry it took almost 12 minutes. The multiple choice are always the lowest scoring problems when we do exams. So make sure that you're giving it adequate time, because it is that 5 multiple choice questions are 5 points each. So that's as much points as each of the other questions. So this is a third of your test. So you really want to think about giving it a third of your time, or making sure that you have enough time in there. Everyone thinks it's going to be easy because it's multiple choice, but they do a really good job being tricky on these. So give yourself a chance. Take the time.